Assalamualaikum warahmatullahi ta'ala wabarakatuh, and a very good day to all of you ladies and gentlemen. So today we are going to look into the new topic which is in chapter 11. The topic is about deformation of solids, and it takes 2.5 hours to complete all the topic. So first of all, I would like to explain to you what is the meaning by deformation. Deformation means the change in the shape, the change in the form actually of a solid. As you can know, as deform means the change or altered. The shape of the solid has been altered. And in this chapter consists of stress and strain. And at the end, this chapter should be able to distinguish between the stress and strain, or tensile and compression force. And then we're gonna look into the discussion of a graph of a stress strain for a metal under the tension. And the other part of it, we can look into the discussion of elastic and elastic deformation, elastic and plastic deformation. And then we look the last part of it. We can discuss the graph of force, elongation for brittle and ductile material. Ladies and gentlemen, please look into this animation. So, how solid be deformed? This is the example how the solid can be deformed. Initially, the solid rates in its position, and the force is applied to it. The shape of the solid change. As I mentioned earlier, the deformation occur when we apply a force. So the applied force towards an unit area is called stress. So for a solid material to deform, it must happen by stress action, and also together with it with the strain. Let's refer to the next slide. Stress and strain. First of all, let's look into the definition of stress. What is stress is about? Stress is a measure of how strong the material is, and in physics, stress itself is defined as the ratio of the perpendicular force to the cross-sectional area. And stress also noted as a sigma. The equation is sigma is equal to F over unit of area. And F is the force that is act perpendicular to the cross-sectional area. So which means the force applied must be straight away perpendicular to the area, and A is the cross-sectional area. The unit of stress is Newton per meter square, or also can be noted as a Pascal. Next slides are referring to the type of stress. There are compression, tension, shear, bending, and also the torsion. Each of the type of stress need force, but in a different direction. As you can refer the compression, the force applied to make solid smaller, while the tension to make the solid longer. The main stress that we should learn, that we should know during this matriculation program is the first is the tensile stress, cause the object to change their length. And then we have a compressive stress which compress the body. So the tensile stress make the object or the solid longer, while the compressive stress make the body shorter. And the last one is a shearing stress. Cause the change in the shape of the body without affecting the volume. Ladies and gentlemen, another factor that makes a solid deform is strain. What is strain? Strain is a measure of how much an object is being stretched. So, in physics, the strain itself is defined as the ratio of the extension E to the length, noted as L naught. It has no unit. The type of strain, firstly, is a tensile strain, which is the ratio between the elongation over original length. Also can be noted as delta L over L naught. As you can refer to the animation, how the process happen. The original length of the solid is stretched to this occasion we call strain. Next is the compressive strain. The compressive strain is equal to compression over the original length, which is also equal to delta L over L naught. And last one is the volumetric strain, is a change in volume over original volume. So, after all, we can conclude that difference between the stress and strain can be noted as in the table. Stress is a measure of how strong a material is. The strain is the measure of how much an object is being stretched. The formula itself, both stress and strain are different. Stress is a sigma and the strain is a epsilon. And then the stress itself is the ratio of the perpendicular force to the cross-sectional area A, while the strain is the ratio of the extension to the original length. And the unit for stress is Newton per meter square or Pascal, while the strain have no units. Ladies and gentlemen, the study about the characteristic of the definition of the deformation process can be represented by the graph of stress strain for a metal under tension. Everybody please refer to the graph shown in the slide. This is the graph of stress over the strain, and the stress strain graph has several points from O point to A, B, C, D, and E. Every point describes different character, different behavior of a solid under the stress and strain equation. So, first of all, let's look into the point of the graph between O and A. So, between O and A in the graph, the force increase linearly with the extension until point A, where point A is called the proportionality limit. The straight line of the graph OA obeys the Hooke's law, which states below the proportionality limit, the restoring force Fs is directly proportional to the extension. By using the equation formed due to the Hooke's law, Fs is equal to negative Ke, and the negative sign indicates that the restoring force is the opposite direction to the increasing extension, which means the longer the extension happen, the greater the force. The same goes to the vice versa. Next, let's look what do we have at point A. At point A is called the proportionality limit. If the stress does not exceed the elastic limit, the B, the wire will return to its original length when the stress is removed, which means the object return back to its original shape beyond this point. Let's proceed to the point B. At point B, we call it elastic limit. At this point B, beyond this point, the material is permanently stretched and will never return to its original shape and length if the force is removed. So, at this point, the shape of the solid is no longer at its original shape. It's already deformed or changed in the form. So the material we call has the permanent extension, and the permanent extension we can get from point O to point T of the graph. You can refer in the graph. And then the area between the two parallel lines OA and CT represent the work done to produce the permanent extension of OT. Next slide. At OB point. OB point is the region we call as elastic deformation. At point C, we call the yield point. So the point at which the plastic deformation begins and the strain start to increase rapidly. At this point, over the yield point, the extension become larger. CDE point is the region we call the plastic deformation. D point, the next point is D, and the D point is the force stress or stress on the material is maximum and is known as the breaking force. This is sometimes called the ultimate tensile strength, which have the greater force before it breaks. And the E point, this is the point where the material breaks or fractures. We call the breaking point.
Hi, how are you today? I hope all of you are good. Today, I will proceed this lecture with subtopic deformation of solid. After this lesson, you are able to discuss elastic and plastic deformation and discuss graph of force or stress versus elongation or strain for brittle and ductile material. Now we go to first learning outcome. Discuss elastic and plastic deformation. Now I want to show a simple animation. From that, what can we observe? Why the material expand? The material expand because of the force was applied to it. Next, you can see the material return to original shape. Why? The material will return to original shape when the force was removed. It's called elastic deformation. Elastic deformation. Elastic deformation is defined as the force or stress applied on a material. The material will expand. When the force or stress is removed, the material will return to original shape. The force applied should be not exceed elastic limit. Let us see second animation. When the hammer hit the iron rod, what happened to the iron rod? Is the iron rod will bend and return to its original shape or not? Oh, the iron rod permanently bent. Why that happened? When the force applied beyond the elastic limit, the material cannot return to its original shape. When this happens, we can say that plastic deformation was occur. Plastic deformation is a process When the force or stress applied on material, the material will expand or change in shape. The material cannot return to its original shape. This only happens when the applied force is exceeded or beyond elastic limit. This is the graph of force versus elongation. From that graph, we can see elastic deformation region. Elastic deformation region from point O to point B. From that graph, we also can see plastic deformation region. Plastic deformation region from point C to point E. I want to show the distinguish between elastic and plastic deformation. First, in elastic deformation, extension does not exceed the elastic limit of the material. That's why the material will return to original shape. In plastic deformation, extension exceeds the elastic limit of the material. So, the material cannot return to original shape. Second, when stretching force is removed, the wire returns to its original length. So, that's obey Hooke's law. When stretches force is removed, the wire is not returned to its original length. The wire is permanently lengthened for in plastic deformation. So, does not obey Hooke's law. Third, in elastic deformation, does not change internal structure of a wire, but in plastic deformation, change the internal structure of a wire. Finally, the energy stored during elastic deformation and energy is converted into heat energy during plastic deformation. Okay, we are done for a first learning outcome. The second learning outcome is discuss graph of force versus elongation for brittle and ductile material. Before we start, I would like to explain the behavior of material under deformation can be described by the following mechanical properties. First, strength. Ability of a material to withstand a force without breaking. Second, stiffness. Stiffness resistance of a material to change in shape and size. Third, ductility. Tendency of material to change its size and shape considerably before breaking. Brittleness. Tendency of a material to break without deforming. What is ductile material? Ductile material undergo plastic deformation before breaking. Example, steel, copper, aluminium. How about brittle material? Brittle material do not show plastic behavior. Example, glass tiles. Let's test our understanding. Which material is brittle? Right or left? The answer is left. From the first graph, when the elongation in plastic deformation region from point C until point E, we call ductile is occur. Refer to the second graph. When the elongation beyond the breaking point or point E, we call brittle is occur. Now, I want to show the distinguish between ductile and brittle material. First, for ductile material can be drawn into wire by stretching. But for ductile material, easy to break, crack or snap. Second, for ductile material, show deformation, but for brittle, do not show deformation. Third, ductile material affected by temperature, while the brittle affected by pressure. Major example of ductile are metals, and example of brittle are ceramic and glass. I think that's all for today. See you in the next lesson. Thank you.